Thank you for coming back for our 10th video on calculus and our discussion on L'Hopital's rule, which is demonstrated on the board. So for a function, for a group of functions, f of x divided by g of x, if we take the limit as x approaches a of these functions, we can state that the derivative of f of a divided by the derivative of g of a is equal to the limit as x approaches a of f of x divided by g of x, as long as f of a is equal to g of a is equal to 0. So we're going to go through a couple examples and then I'm going to go over a proof that shows that this works for any derivative as long as these conditions are met. So for example, let's go back into the squeeze rule that we learned in the first video. So limit as x approaches 0 of sine of x over x. For example, so if we were to apply this, f prime of a is cosine, a is equal to 0, so cosine of 0 divided by g prime is 1. Cosine of 0 is equal to 1. Now our second example, limit as x approaches 2 of x squared minus 4 divided by x minus 2. Now if we remember from the first video, we can algebraically manipulate this so that we can get x plus 2 times x minus 2 divided by x minus 2, and we get rid of these, and let's just not forget that limit x approaches 2. So we get limit as x approaches 2 of x plus 2 equals 2 plus 2 is equal to 4. Now we're going to be using L'Hopital's rule to apply to this. So if we take the derivative of the top, this is equal to the derivative of the top at evaluated at x is equal to 2 is 2 times 2 divided by the derivative of the bottom, which is 1, is equal to 4. Let me just fix this up. Okay, so now I'm going to quickly prove that we can say this is true. Okay, so if we can remember that f prime of a over g prime of a is equal to the limit as delta x approaches 0 of f of a plus delta x minus f of a divided by delta x divided by limit as delta x approaches 0 of g of a plus delta x minus g of a divided by delta x. Now, earlier we stated that the condition has to be that f of a equals g of a is equal to 0. So we can get rid of these two. And we end up with, and we can also, because these are limits as delta x approaches 0, we can get rid of the delta x's. So we end up with limit as delta x approaches 0 of f of a plus delta x divided by limit as delta x approaches 0 of g of a plus delta x. This is equal to f of a over this is not equal to f of a over g of a. This is equal to, because we already stated that f of a equals g of a equals to 0, we can get rid of the delta x's, but we also want to create a new limit because we have, when x is equal to a, we have 0 over 0, so we want to find limit as x approaches a. So we can redefine this limit as the limit as x approaches a of f of x divided by g of x. Q, E, and D. So, thank you for watching our quick video on L'Hopital's rule. I look forward to seeing you in our next series of videos as we introduce integration. So, that's just about it for derivatives. So, as always, if you have any questions about this or anything in calculus in general, please post as a comment, and I may consider doing some supplemental videos, just doing problems, in case some of you have issues. And if you feel that a problem is really stumping you, then while you're learning, then I can do a video where I am solving that problem. So if you wish to, you can ask any questions in the comment section below, or you can also subscribe, which would be greatly appreciated, and share with anybody that you know. So, thank you for watching, and I will see you in part 4.